Good morning, everybody, and a very warm welcome to the Eastbourne and Seaford Eco Homes event. We thank you for joining us this morning, and we hope you haven't had to travel too far. I appreciate you could all be doing other things on a Saturday morning with friends and family. The fact that you have made space today to join us for this event, for us to join together in engaging with the challenges of climate change, of reducing our carbon emissions and moving Eastbourne and Seaford to a position of lower carbon emission, I and we as a group want to honour your commitment. We are here in support of our pledge for a carbon neutral town by 2030. The event is brought to you by the Eco Action Housing and Energy Working Group and the Seaford Environmental Alliance. The domestic sector is presently the largest single contributor to our CO2 output, and by fuel type, gas within the domestic sector is the largest emissions source. Therefore, our homes are an area where we can make great inroads into reducing our emissions, and there are actions we can all take at a local level. This event provides information and invites discussion on how we can live more sustainably and move towards our carbon neutral goal. I will now hand over to our event organiser, Jill Shacklock, to introduce the resources, the structure of the morning, and our speakers. Thank you, Jill.
Thank you, Tondra. Well, this event has been a long time coming. The idea was first suggested by Brian Jones, who was a member of the Energy and Housing Group. And Brian had wanted to set up an open house day for Eastbourne and surrounding villages, where residents who had installed eco features could open up their homes for an afternoon and answer questions. And I was very happy to join him in planning this event. But along came COVID and we postponed the event for a year. Then a year later, it looked like we still couldn't run an in-person event. So we've decided to run an online event. Sadly, Brian died in spring of 2021 and didn't get to see his idea come to fruition. And many of you on this call will know Brian, as he was a very active environmental campaigner and a champion and a big thinker. And the world of today needs a lot more Brians. So today is for Brian. We're going to be exploring the issues he was exploring and working out what we each can do, because we can all do something to reduce our carbon footprint. And Brian took some pretty big, bold steps, including installing a ground source heat pump in his garden. But as a short person, I can say that little steps can also make a difference, especially when lots of us are taking them. Before we introduce our first speaker, just a few little bits of admin. There are 3 sessions today, and there's going to be a short break between each session. Hooray. And each session will conclude with a Q&A. If you'd like to submit a question to our panel, please use the Q&A feature, not the chat. And use the chat to start discussions with other people in the audience. But remember to be kind, we're all in this together. Each session today is supported by resources on the event website. The resources were there for you to look at before the session, but if you missed them then, you can look at them afterwards. So I'm just going to share my screen. Bear with me, I shall share that screen. Okay, so just quickly on the event website. So the event website has the 3 different sessions. So if I just take you to the session for our first session that we're in now, you'll see some things that are on there. There is a video interview with Councillor Jim Murray, who is on our panel today, and Jim is talking about building policies and planning. There's also a video interview with Alan Shuttleworth on social housing, new builds and retrofits. We have a video interview with Marc Pope, who is from the Construction and Industry Training Board. And Marc is talking about the new retrofit training and qualifications. So if you work in construction or are planning a retrofit with public funding and grants, he's got some very useful information there. There are 2 new roles with qualifications on retrofit awareness and retrofit coordination that are mandatory for public retrofit works. We've also got an interview with Dick Shone from Boutique Modern, who do modular housing. I hope you've seen it already, because Dick is on the panel, so you'll be able to fire lots of questions at him. So a big welcome to Dick. And information also on fixing your front drive, if that's something you want to do. And also we have Eastbourne Borough's climate emergency strategy. So I will attempt to stop sharing. That's the
Sorry to interrupt you, Jill. We didn't see your screen there.
Oh, really?
It's a slight
Okay.
technical glitch. Do you want to just try again? See if you can share that screen and point out.
I will do. Right, bear with me. Okay, so can you see the screen now? Can you see the screen now?
Yeah.
Okay, so sorry about that. I won't go through all the waffle again, but basically on the section on building in the age of emergency resources, you can get a link to Duncan Baker Brown's bio. And we also have interviews with Jim, Alan Shuttleworth, Marc Pope, Dick Shone from Boutique Modern, and Eastbourne Borough Council's climate emergency strategy. So all of those events are online and they'll be there afterwards. I shall now stop sharing. And just checking whether there's anything else I need to tell you. So those events will be there, but I think that's one other thing that's on there. There is a free retrofit training course from Low Carbon Trust, which looks really useful for explaining the science behind retrofitting in an easy to understand way. And that's always useful, whether you're planning to do a retrofit yourself or pay someone else to do it. So I do recommend having a look at that retrofit course. But enough from me. It really does give me great pleasure to introduce our first speaker. But where to start and where to finish, just know that Duncan Baker Brown is an incredibly active and respected climate champion, a sustainable architect, university lecturer, and creator of wonderful things. If you want to know more, follow the link to his bio. I'm just going to say that he's a very, very busy man, and we're very lucky to have him launching our event. And I feel very sure that Duncan is going to set the tone for the day, inspiring and motivating us to make the changes we need. So I'd like to hand over to Duncan.
Thank you, Jill. I'm blushing. That was a lovely introduction. Can I just say what an amazing event this is? I mean, I am busy. We're leading up to COP26 and I'm just banging on everybody's doors trying to be involved in stuff. So I'm making myself busy, but this is such a good event with the resources, etc., that you've put together. So congratulations to you and your team. It's a brilliant initiative to be in. And yeah, it is 10 o'clock on a Saturday morning, but I'm very glad to be here. I'm going to share my screen now. And can someone tell me if they can see it? Yeah, thanks, Jim.
Yeah.
Okay. Just need to. Okay, here we go. Well, yeah, thank you. I describe myself as an architect, academic, author, and activist. I just need to change the presentation because I've got people's images all over my images. Okay, yeah, two questions. What are the real challenges to adopting an authentic, sustainable existence with our host planet? And why aren't more people with power concerned with their own business as usual policies? Okay, some good news. Back in 2019, that was the year that 90% of local authority regions committed to being net zero carbon by 2030. That's 60 million citizens living in these regions. And around the world, we've got about 1 billion people actually now who live in places that declared a climate and ecological emergency. So what should we do next? I can't believe, but this is the main argument. Can we afford to do the right thing? Can we afford not to? Doesn't seem to be such a big question, but really, a lot of people are saying the right things, but they're really thinking this. Then we've got good Boris, bad Boris. Good Boris saying that the world needs to grow up. Bad Boris saying build, build, build. Old school style-y. I mean, it's just words. And perhaps this is the truth of it. This is our legacy. And yeah, to a certain extent, are we all climate emergency deniers one way or another? Yeah, it's a difficult thing to get our heads around. So why should we care? Well, there's no vaccine, of course, for the climate and ecological emergency. So why us in the construction sector? Well, we consume 50% of all the world's mined and harvested raw materials annually. And it's the environmental destruction associated with this process that is one of the main factors in generating the current mass extinction of species. And 10 years ago, that amount of materials mined and harvested annually was between 45 and 60 billion tons. We're now up to 100 billion tons. So the construction sector consumes 50 billion tons of stuff a year around the world. In the UK, we consume 600 million tons of products a year. The UK generates about 200 million tons of waste, and 60% of that is from the construction sector. That's 120 million tons of stuff going to landfill and incineration annually. And nearly 50% of all carbon emissions, when you look at the sort of maintaining, operating and building and deconstructing of the built environment, are to do with the built environment. So yeah, we're pretty much half of the problem. So humankind needs to learn how to manage planet Earth's resources properly. And it's often about managing resource. So it's all about managing resources and dramatically reducing the need to consume raw materials. And it's designers and constructors that do the consuming. So for example, if you're in the world of construction and you design a 10 by 10 meter concrete slab, and you decide to make it 50 mil thinner than normal, you will save as much CO2 as if you avoided, as an individual, meat for a year. So the construction sector is something that if you're involved with it, you can make a huge impact on the environment, maybe compared with some other jobs. Now, we currently live and exist as a linear economy where we take materials, we make them into things, use them for moments and then throw them away. We are literally the only system on planet Earth that does this. Everything else is a closed loop circular economy. And in the human interpretation of this now, because of the way we live and the stuff we've made and designed and the stuff we rely on, we need two circular spheres. The biosphere, which is organic and natural, it's where we grow things, we produce, we make things out of those grown materials, and then we use them, we adapt them, we reuse them, we mend them. And ultimately, if we don't add toxins to them, they become compost for other things to grow. So that's a nice circular organic biosphere. But we also make things that don't compost, obviously, and it's the tech sphere we've really got to work on. And I'm not sure if you can see me or not, but pretend you can, or if you can, yeah. I'm holding a Fairphone. Now, this is a smartphone that when you buy it, it arrives with a screwdriver. And that is a totally different sensibility to normal smartphones, which are deliberately designed as sealed units. So if a little thing goes wrong, the whole thing needs replacing. With a Fairphone, not only the ingredients of the phone safe and not harming people, sorry, I stuttered then, but if the camera goes wrong, for example, you just unscrew it, send it back to Fairphone and they send you a replacement. So in the world of a circular economy at the moment, for example, BMW would tell you that 80% of their car is recyclable, but not into BMW cars. In a circular economy, old BMW and old BMWs are the source material for new BMWs. So the good thing is that everybody's talking about it. You know, this is from early 2020, just before COVID, a case for never demolishing another building. So working with existing built-in fabric is the thing you need to do. And a lot of people are looking at this idea of not demolishing, just adapting and reusing. And it's interesting that the biggest prize in architecture, the Pritzker Prize, this year it was L'Aquitaine Basel who won it with this strapline, never demolish, never replace. And I'll show you a bit of their work later. There's also campaigns for zero VAT on retrofit projects, and all of you involved in adapting your houses will know that you have to pay VAT on of 20% on labor and materials to upgrade your house. But if you are in a position of demolishing it and starting again, new build houses are zero rated. So we've got an unfair playing ground at the moment. Yeah, and this is a slide that probably gets people either annoyed or passionate or whatever, passionate anyway. can you believe it that something as dull as insulating Britain is now a huge campaign that's getting a lot of people annoyed, direct action campaign in the name of retrofitting our homes so that we have low carbon, carbon resilient, healthy homes. It's a human right. But we're at such a point in history now that this is the sort of action that we need to get our central government thinking seriously about retrofit. So the other thing is that over 80% of today's built environment will be with us in 2050 if we demolish at the same rate as we have done previously in the UK. So that means if you look outside, that there are future eco-towns. They're with us already. They're the things that were in places that need to meet the net zero carbon target. So retrofit is a huge, big deal. The other thing about reuse is if we're reducing the consumption of raw materials by adapting what we've got, then we can close down these places. And this is a photograph of an open cast copper mine in South America. You know, I don't know how many people on this call know people that are miners, but it's not a job that humans ought to be doing. And if we can close these mines and then mine the Anthropocene, rework the stuff that's been mined and produced previously, the Anthropocene being the current geological epoch that we're in, the human-made layer of stuff that wraps the planet. If we can rework that, close down the mines, and then regenerate natural environments or let them get on with it themselves if we're out of the picture a bit, that's got to be the way forward. So my point of view is we actually know what to do. And there's lots of guidelines now. The RIBA has its 2030 climate challenge, the wonderful London Energy Transformation Initiative, LETI, they're bringing out guides all the time. They're about to bring out their retrofit guide. So they brought out their climate emergency design guide. We've got a lot of people coming up with a consensus for a whole life carbon descent plan. And this is from LETI's document. Literally, you know, the graphics are nice and clear, giving you key milestones between 2020 and 2050. And what they're realizing is this concept of embodied carbon is now the big, big deal. So embodied carbon is the amount of carbon and stuff that goes into the design and manufacture of a thing. So in the case of a house, what's the carbon footprint of the house to get it built in the first place? And we in the past, not many people have thought about that as an idea, but the resources that go into the design and the construction of a house or a city before it's occupied is a big, big deal. So if we can reduce that, that is going to reduce the overall carbon footprint of the proposal. We've got other plans, like London's got its circular economy route map, which is a part of the current London plan. We're about to publish Bright and Hove's circular economy route map for the construction sector. So it's being taken very seriously, this idea of circular systems. And I'm just going to run through some circular economy principles now. I wrote a book about it called The Reuse Atlas, A Designer's Guide Towards a Circular Economy, and that's published by the RIBA, and I've just started writing the second edition of that. This was published in 2017. The point of the book was to show delivered, cost-effective examples of buildings, but also examples from the world of fashion and textiles and product design. And I broke the book down into 4 key steps. The first step being the most basic thing to do, and the last step, step 4, being actual closed loop circular economy systems. And the first basic step is recycling, and we've got our heads around recycling, but it is only the basic step. The reason being is because you get materials, you gather them together and either melt them, shred them, or whatever into material sources. Now that whole process creates pollution, consumes energy, and creates waste. So get the terminology right. The next step is a lot better, and that's reusing. So it's literally, if you've got a glass bottle, you wash it out and reuse it rather than smash it up into, and you can see the difference. So that's why reuse and retrofit and adaptation of the built environment is the big deal. Reduce. is a big deal. And I'll show you some projects. And that's what Lacatin and Vassal, the architects that won the Pritzker Prize, that's what they're really good at. Turning up at a situation where you think, say, you're going to spend 4 million euros, and you're going to use tens of thousands of cubic meters of stuff. They say, well, actually, you might not need to do that, and you can achieve the client's end needs. And that's really inspirational, that side of their work. And then the last step was closed loop circular systems that emulate natural systems. Now, one of the concepts from the circular economy is this idea of urban mining, which is searching for new material sources to reduce the need for natural raw materials. And it's called urban mining because our urban environments, towns and cities, are where the materials and stuff flow to and through. And normally, because it's a linear system, they go out again. Some hang around, obviously, and become houses and and stuff and hanging around and what have you. But there's a lot of materials that flow in and out of cities. So cities are great places for mining. And you need to consider your cities and towns as material stores for the future. And I deliberately show this aerial shot of Brighton because obviously there's a lot of conservation area in that photograph. And there's areas that are less valuable in terms of from that point of view as well. But I'm acknowledging the challenges that go along with this. But I would also say that majority of the buildings in this photograph are material stores for the future. They're easy to adapt because they're lime technologies, et cetera, et cetera. So these are buildings that are designed predominantly in this photograph as material stores for the future. I'll just briefly dwell on this, which was a project all about urban mining. We gave ourselves this challenge of designing and building, it wasn't a house, or it isn't a house, it's called the Brighton Waste House, but it's actually a teaching facility on campus at the University of Brighton. And we said, right, at the time, for every 5 houses being built, 1 house worth of waste went to landfill and incineration. So 20% of everything arriving on site was being thrown away. And this is why off-site prefabrication is such a big deal, a positive big deal, because the waste is almost reduced to zero with those sorts of systems. So what we said is, right, we'll find that waste stream and we'll construct a building to really low energy passive house standards made out of that stuff that people threw away. And in this case, 90% of what you're looking at there is material other people threw away. This building, this is the first permanent building made in such a way to perform at such high standards. It creates 30% more energy than it consumes. And by the way, it was built by 360 students from what's now Brighton Met and the University of Brighton, as well as apprentices. Yeah, in only a year, it was under budget and on time. And this was a diagram, an infographic, where we're trying to explain the amount of material that went into making that building. Now, it's well known as a building because we use 25,000 toothbrushes and DVDs and things like that. We're not saying that's what you should build a house of, because what happened is that this project went from being a project all about reusing construction waste and pointing out that it's not waste, it's a resource, but it went to a sort of bit more of a polemic, a thought, something that's going to sort of provoke thinking for the people who are using it and other people. So we started to think about the sorts of things that are thrown away by humans on a day-to-day basis. So of course we got toothbrushes and things like that. And so the message got a bit muddied, but it's become this sort of vessel containing hundreds and thousands of products without an end-of-life strategy. And that's what we need to do. We need to design things that have a healthy, from the planet point of view, end-of-life strategy. So the one example of this, which is a product without any end-of-life strategy worth being proud of at all, are toothbrushes, plastic toothbrushes. And we collected 25,000 of them in only 4 days, because we went to Gatwick Airport and one of the cabin service companies there who clean out airliners when they arrive from New York, do the transatlantic route. If you do that route, you're given a toothbrush. You never use the toothbrush. So the toothbrush is given to you, you take the flight, and then it's cleared up by the cabin service company. They collected 25,000 of those in only 4 days. So if you think about the story behind that product, it was a fossil fuel processed into a plastic, processed into toothbrushes, put on an airliner to fly across the Atlantic to land in Gatwick to be cleaned up and sent to incineration. That's its life story. So we've got to get away from products that have that sort of linear, dumb end of life strategy. The project has attracted other EU funded projects where we were asked to locate local waste streams that we could turn into products for the construction sector. So there's been a lot of demolition in Brighton recently, so there's demolition waste, but there's other waste flows. So here we notice near the waste house itself is English's restaurant, throws away 50,000 oyster shells a year, and we played around with those oyster shells and other waste materials, including duvets. That's the fluffy stuff you can see at the back. It's cheaper for students in Brighton to buy a new duvet than it is to get one washed, so it's a huge problem in Brighton. But anyway, the waste materials we turned into these tiles, and the one that Ben's holding there, the white one, is made out of 100% oyster shells. And they're busy curing on the side of the waste house at the moment. And they're basically concrete tiles made out of waste material. In the case of the white one, 100% organic waste material. We've also recently, this summer, I won't dwell on it too much because we've got lots of time, but Brighton and I would say Eastbourne, New Haven, Seaford, these coastal towns, we're generating a lot of interest with a lot of interesting projects at the moment. We did a digital summer school for 120 people this August, looking at the idea of reuse. This is the image on the left is from a client of mine who's got a project in Walthamstow in East London. Oh, my slides are jumping. And the slide on the left there is bricks that he's hand thrown on site, made out of spoil from one of his sites. So he had 100 cubic meters of extra spoil from his site that would normally go to landfill, and he's actually made hand thrown bricks out of them, and they'll be used for his next project. Now, these people are the inspiration for a lot of what I do, and they were part of our digital summer school. And they're called Rota Deconstruction, and they're based in Brussels. And you view these slides from the top left to the bottom right. They deconstruct buildings that are normally demolished, and they take them apart one screw at a time, and they unpack them, and they put the resources, advertise them online, and they've got their own warehouse as well. And they put this stuff out into the supply chain. And you can buy secondhand material from these deconstructed buildings. And at the moment, they're deconstructing the part of the World Trade Center in Brussels. And if actually I go back to that slide for a sec, this is the sector. This is a bank building being stripped out and deconstructed. If you think about the financial districts and business districts around the world, these are the buildings that when they get fitted out initially, if they need to have tenants, they have a temporary fit out to attract tenants. The tenants occupy the new buildings. The first things they do though, before they occupy, is strip out that interior, throw that interior away, brand the building for themselves. And then 7 years later, they do the same again. And the age of these buildings can be as young as 20 years before they're demolished, because these financial institutions are wanting to show the brand new face of the institution. So this is where a lot of the consumption's happening. And so to be able to go in there as they are here and carefully deconstruct instead of throwing this stuff away is hugely impactful. These people, the Ecological group in Denmark, here what you're looking at, a typical 1960s building there on the left, a brick building. And the thing about brick buildings from the 20th century and now is that the bricks are stuck together with a cement-based mortar, which is stronger than the brickwork. So you're never going to get secondhand bricks like you can with buildings that have got lime mortar, earlier buildings from the 19th and 18th century. But here what they've done is get to the building with an angle grinder, and they got 4 of these buildings, cut them up with an angle grinder into squares, and then they put them together again to make new housing, which is quite amazing. So this is one little bit of it. It's quite a large housing scheme. Again, that's about 20% of the scheme. They actually allowed the builders to compose the panels themselves. So they've just got 4 brick types and played around with the patterns. This is Maurer United Architects from Maastricht. And this is an unusual situation. They've got population decline in Maastricht, in one area of Maastricht. So these tower blocks are actually empty. So they were due for demolition, and some of them did get demolished, but then Maurer got hold of one, and they did a bit like the Ecological group did. They cut them up. So they cut the flats up into individual units and made houses out of those individual units. So there's a house being constructed out of a bit of flats. So all that material didn't get thrown away, which is incredible. Now, this is the Lacatin and Vassal project in Paris, which, if you've heard me talk before, you would have heard of this project, but I think it's worth speaking about every time I have the opportunity to talk to people, because it shows design for me being, at its best. It's clever design. So this tower is a residential tower in Paris. It was due for demolition, and the mayor of the city had the money put aside for the new tower, and Lacatin and Vassal approached the mayor and said, we can give you your new tower for 2/3 of the price that you expected to pay for it. And they hummed and hawed for a decade, actually, and went back to the architects and said, yeah, we'll do that. How are you going to do it? So they said, well, the first thing is we won't demolish the tower. And this is the diagram that explains what they did. So on the left there is the apartment as it is at the moment, typical apartment with its existing concrete panel facade. And all they propose to do is remove the facade and then add one of these winter gardens, which, if you can see my cursor, is one layer of double glazed sliding units, then 2 meters of extension, then another layer of double glazed sliding units, and a balcony. Now that device is an unheated bit of space that when you put on all the apartments, you've wrapped the tower block in insulation, in effect. And the balcony stops in the summer, stops the winter gardens overheating. The blinds in the winter stop glare. The large opening doors allow for ventilation and natural light. All in all, a lot better situation than the tenants had before. And this is a slide on the left. You can see these things being bolted on. Now, the great thing about this project is the tenants weren't dispersed. They could stay in the tower while this happened. And that's the before and after shot. They didn't decorate the apartments. They didn't spend money on the apartments at all. They just took the grotty old wall off and added the new stuff. And here you can see the benefit of it. And yeah, when was the last time that you got an extension on a property for nothing? I mean, this is architecture working hard for you. So the utility bills at this place, because they don't have to turn light bulbs on during the day, they're not overheating in the summer and being freezing in the winter. All these things are solved. Their energy bills are reduced by 40%. Now, this is another example of building reuse. This is Cleveland Steel, who needed a new building. They're based in the north of England, and they found their new building in Dublin. It was an existing building. It had a 3D, what we call BIM model, building information model. So they thought, right, with that tells you all the different components of the building. So they bought that building, they deconstructed it, they assembled it in their yard, and this is it being assembled. It wasn't quite as the BIM model has described. They had a bit of remedial work to do. It was a little bit of a faff. It wasn't as easy as they thought it was going to be. But the bottom line was, with only a £5 million budget, they saved nearly £1 million. So, what's not to like? It involved a little more design time and thinking. But that investment at the beginning, which is going to be the theme for all these projects, you need that investment at the beginning to learn how to retrofit, if we can talk about retrofit, how to do it properly, and then get going, and you will save money. Now, I've used this example because this is from the City of London. This is brand new. This is number 1 Triton Square, Lend-Lease for British Land. This is as commercial as you want. And this is a building that's 19 years old. It's now 20 years old. It's been refurbished. It wasn't knocked down. And the exciting thing was that glass facade that was 19 years old, they took it down, they cleaned it up, and they put it back up. They upgraded the glazing mullions. Now, the reason they were able to do that and get the guarantees of performance for that second-hand facade, or the old facade reused and revamped, is that the supply chain was still live. The company still existed. And so that's the opportunity you've got in these financial districts, is that the buildings that are being torn down are so young that the suppliers still exist. And then on the right here, you've got all the statistics that 33,500 tons of concrete kept in situ, not crushed, 1,800 tons of steel reused. All these things the benefits on the environment and the resource chain are huge if you reuse. Okay, now all of that going forward, if that's the way we're going to operate, we do need sort of big data and smart cities, and the digital tools and databases are emerging now to allow us to do this. So this was a practice in Rotterdam called superuse, and this is from about 2013-14. They invented something called a harvest map, which is a live interactive map telling you where stuff is. So it's a bit like Freegal, but with a digital map, but also for construction. So they've done that. This is Metabolic, also from the Netherlands, and they quantify the flows of stuff, energy, water, food, materials, stuff in cities. And here you've got a 3D map of the greater metropolitan district of Amsterdam, and they're mapping the construction material on those individual sites. In other words, the buildings that are standing there, what they're made of, and their ability to be reused and recycled if you're having to renovate them. I'm going to just dwell quickly on a couple of, I think I've got another couple of minutes, a couple of projects that are very local where we're employing these sorts of ideas. So I think most of you would have know about Glyndebourne Opera House, even if you don't go there. But here you can see a photograph of the Opera House. We're doing a project on site here. You probably know that it's got a big wind turbine that actually creates more electricity than the site needs. So we employed one of these resource maps for this project, looking at materials that were on site and in the general vicinity that we could use for the project. And so, for example, number one is, oh, that's moving. Number one is under-fired bricks from Chailey. So we go to Chailey Brick Yard near to where I am at the moment, where I'm broadcasting from, and they make lots of lovely bricks, but that process means they also have a quantity of under-fired and over-fired bricks that they don't sell. They normally throw those away. We can use those. Then we're looking, here it says oyster shells number 2. We're looking at food waste from the Glyndebourne restaurant. We're able to collect food fibers to make into tiles for the building, and also shells that we can use again for making concrete tiles. The other thing, which is, excuse me, I just need to get a drink, which we're really interested in using more and more of, and we have at Glyndebourne, is ash dieback. It's unfortunate, obviously, they're having to chop a lot of trees down all over Europe and the UK for ash dieback, but those trees at the moment are just being sent to be chipped and to be burnt. Well, ash is a beautiful timber, so we've used the ash that was chopped down on site. We've collected that and we're using it for the structure of the building. We're also collecting corks and glass, and there's a lot of chalk on site that we can use again to make mortar and plasters and renders. And number 5 is the unusual one. We're looking at using mycelium, which is mushroom roots. We're working with a company called Biome who are developing mycelium insulation. So here's the ash. I mean, there's a photograph of it on the right. That's what's being chopped down and chipped at the moment. It's the most beautiful timber. This is chalk on site. Actually, we found chalk. There's a pile of chalk next to the wind turbine, which was dug out when they put the foundations in for the wind turbine. So we're actually using that for plaster. We're collecting bottles at the moment. The Opera House has been functioning at 50% capacity for the season. So that actually means 36,000 bottles of wine and champagne drunk. So yeah, we're collecting those. With the glass is being broken up, and we use it in tiles on the floor. We're collecting corks. Sorry, my slides are all over the place. There's the over-fired bricks there on the left, and here's the sample of some of the floor and wall finishes we're using for the pavilion. We're making tiles for the outside of the pavilion. Now, this slide shows you what food waste can be turned into. So this is the top left is cork and orange peel. The dark black one in the middle there at the top is coffee grains. Top right is grass. The front one is grass as well, and the bottom left is a combination of a lot of them. And this is 100% grass plus orb, which is a material that an organic material, binding material that Biome have produced, and these are ideas for light fittings for the building as well. And this is what mycelium insulation looks like. It's about to get its BBA certificate, British Board of Agreement certificate. We will not be using it unless it gets this. At the moment, it performs the same as the nastiest PUR plastic insulation, which is amazing. It's got far better fire resistance, and it's great with moisture. And the difference is, at the end of its life, if you put it in the ground, it would decompose within a few weeks. If you do the same with plastic, we all know what happens with plastic. It doesn't go anywhere. So that's just a summary of the pavilion and the materials. There's a couple of views of the pavilion. And I think I'll leave it there. What I would say is I'm really optimistic for now, because everybody's talking about this. We've got COP26, where various leaders may or may not turn up. But I think I'm noticing that in all sectors of society now, people are really prioritizing the environment. I mean, on the positive note with COP26, of the leaders that turn up, I don't think there is a leader there that hasn't got wet feet or singed hair from flooding and fires this year. So it's not going away, and we do need to do something about it. The good news is, I think we know what to do. We just need to start doing it right now. Thank you very much.
Duncan, thank you so much. That was a fascinating presentation, hugely informative. Some great comments while you were speaking there. Fantastically interesting and inspiring. There's a lot of support for the Waste House project. So I think everyone has got a lot of takeaways from that very interesting talk. I was particularly fascinated and enjoyed hearing about the mycelium, the building blocks of life. I think it's World Fungi Summit this weekend, World Mushroom Day yesterday. That's fascinating. I look forward to learning more about.
Doesn't sound like you need to. You sound like you know more than I do.
I've just started to really get interested and look to understand a bit more about mycelium. So I've got a couple of questions, but I noticed some questions have come in. So let's start with those. If we run out of time, then the panel may have some questions themselves. I'm going to go over to the Q&A section and ask some questions. One of the first ones is about the coffee grounds and the cup worktop in the Waste House. And the question is, how did that work?
Okay, what's interesting is that Tom, I've forgotten his surname, Tom Bennett, I think, I might be wrong there, but Tom, who was a graduate from the University of Brighton down at the School of Art, he was a product designer. He was making these materials out of recycled coffee grounds and binding them together with resin. So he's getting a source material and then putting it together with resin, which wasn't I don't think it was bioresin initially. So basically he's making a sort of plastic holding coffee grounds, which wasn't so interesting, but he's now using organic resins, which means that ultimately this thing will decompose. But most excitingly, he bought a company called Smile Plastics, which have been going for quite a long time. And so now he's the CEO of a company that are also doing the sort of work that Biome are doing. So he's working with Google to make materials out of food waste from Google's restaurants. So but coffee, the thing about coffee is just obviously so much of it, so what we're doing is plugging into waste streams that are abundant at the moment, and coffee can easily be bound into a material. And with Biome, we're using, as you said, we're using it for interior tiles. Did I answer a question? I don't know what I've done.
Yeah, I think so. I think that's very helpful. I agree. Coffee is something that we see generated every day as a waste product. Yeah. And my parents tip it onto the garden. I don't know. I've heard it might be good for digging into the soil, but if you haven't got garden or soil, then it'd be good to understand what other uses. So if you do collect it up and how it.
Well, if you can imagine the amount of coffee that comes out of Nero's and Starbucks and Costas, etc. I mean,
Yeah. Absolutely. So I think this is another question on the Waste House. I'll read it as written. So it assumes that the house is already fully insulated, loft, cavities, double glazed, sealed windows and doors, and replumbed with efficient radiators and heated with a highly efficient boiler. Question 1, if so, does a heat pump installation, assume that a house, so this wasn't the Waste House, assume that a house is already insulated. to question one. If so, how does a heat pump installation require the plumbing, radiators and boilers? Does it require that to be ripped out and replaced with new? Or can you use that infrastructure?
You can use that infrastructure in some cases. However, yeah, I mean, that's a really interesting question because it's something we're looking at the moment. We're starting a study on retrofit best practice with my University of Brighton Hound, and we're actually looking at one of the things we're going to look at is the waste flows from buildings, from houses being retrofitted. So I think there is a consensus that ground source and air source heat pumps are the way to go. From my point of view, as an architect's used them for years, we've never gone near using them until we've got a very well insulated, well sealed building. So what I would say is if you don't have any of those things, and I think the person asking the question knows what they're talking about because they're saying it would be well sealed and would be insulated. Yeah, you're going to end up with an expensive option if you don't have good levels of insulation and air tightness, because that's how they perform well. They'll only have to be working too hard if you haven't got those things. With regards to the interface between the new technology and the old technology, they should be able to plug in. They're creating an energy source. So once you've got that energy, it should be suitable for radiators. What I would say though is I'm not a fan of radiators because they don't actually act as radiators, they act as convectors. They require very hot water at 90 degrees to work, whereas if you've got underfloor heating, or if you're going to go down a sort of electric radiant option, which is probably a better option, yeah, you're using lower grade heat, which is easier to obviously acquire, and means the ground source air source heat pump isn't having to work so hard.
Thank you.
I would actually say it's quite complicated as well. It's the big thing is, there's this, we do need to retrofit a lot of properties very quickly, but the concern is that they'll just throw a lot of technology at buildings and not be concerned with the bespoke requirements of different buildings from different ages and buildings with different infrastructure in them already.
Yeah, and it's interesting you talk about the buildings of different ages. I mean, one of the things I love most about Eastbourne is the built heritage, the architecture, and the proliferation of sash windows. We still do have a lot of sash windows. So you mentioned in your talk about embodied carbon. UPVC windows obviously is great for insulation and keeping the heat into buildings, but I imagine there must be a lot of embodied carbon in those windows. And in my view, they don't look as good as the wonderful sash windows that the buildings were designed with. So I suppose a question from me, do we have solutions for retrofitting buildings with sash windows that doesn't detract from the character? Yeah, definitely.
I mean, we worked on a project in Brighton called the Nook, which was we retrofitted a Victorian building with 6 apartments in it. It's freestanding, and on the conservation elevation, it was listed the front elevation, we replaced with sliding sash windows with a sort of micro double glazed units in them, air sealants or draft excluders, and internal insulation was internal wall insulation on the front facade. Then on the side and the rear of the building wasn't listed, so we wrapped it on the outside with external wall insulation and treble glazed windows. And that building, which, like I said, 6 individual people lived in, it had 1 solar thermal panel on the roof and one boiler for hot water. And it had mechanical ventilation and heat recovery. That strategy reduced its consumption of energy by 85%. Wow. And it looked, by the bottom line is, it looked like it did in the first place. It did before and after shots. Yes. It looks the same. So it's possible. What I would say is that was £150,000 spent on one property, but it's amongst 6, so you divide that by 6. I can't do the maths now. What's the maths?
Still a
Still not a
reasonable
lot.
amount of money.
But the point is to do the my point of view is to do the retrofitting required of our existing housing. We need to see it as a sort of national infrastructure project.
Yeah.
So, you know, we're talking about £500 billion worth of money spent on on our housing alone, 28 million homes. So we can't do it on our own. We've got to have legislation. We've got to have tax incentives, and we've got to have a sort of a ministry for retrofit that deals with this. That
sounds good. Yes, and
supplies money, and then you can get your building rated, your house rated in terms of its energy performance with regards to the design that you're going to put, retrofit design. And if you're meeting the carbon descent plan targets, then you've got zero VAT and you've got the most incentives. If you're not doing very much, you might have to pay VAT still.
Yeah, lots of support in the chat for 0% VAT on retrofit. Yeah. So that's a very sensible suggestion. A couple more questions, if I can, on the chat. Why are building supply companies not required to take back unused materials?
They should be. I know. I mean, the world out there really. What we've got is the common practice is the worst sort of practice in terms of supply chain, and we have reduced the amount of the amount of waste from construction sites. So now it's every 7 or 8 homes. After every 7 or 8 homes, there's one house worth of stuff going to landfill incineration. But we've got Dick speaking or chatting later. I mean, there's a whole reason why a company like Boutique Modern exists. Is because that and they're on our doorstep, by the way, and that's best practice. We've got to eliminate waste flows. So but unfortunately, but my bottom line point was actually there's a lot of good practice emerging because there's a lot of people acquiring the knowledge and understanding that the current system isn't what you need to do. So that's why I show something like number 1 Triton Square. Lend-Lease, and British Land, all they want is the bottom line best deal. They realised the best deal was not to demolish, was to reuse and to invest in the knowledge.
And Lewis and Eastbourne councils are introducing technical advice notes for new development projects. One of them is circular economy, and I think that touches on some of those aspects. So I think the councils are starting to try to drive behaviour.
What we've got at the moment is councils as sort of first early adopters and pathfinders with all of this, because building regulations are nowhere near what they need to be. So you've got, like I said, Lewis and Eastbourne have got that. They've got their document referring to the circular economy, and Brighton and Hove got the same. And so those things are offered to contractors, and then they just say, well, yeah, you're telling us to do that, but building control don't say we need to do that. So building control's got to pull its finger out and get with a program.
Indeed. A couple of quick ones, hopefully. This one, sort of some big ideas perhaps wanted to hear. How can we change the thinking of big banks and perhaps other firms who want to keep refitting their offices?
Well, they can learn from Lend-Lease and see that you can actually do it. I mean, one project that I didn't show, that famous one for me that Rota did, is they worked with Levi's HQ in Brussels, and they were commissioned, because they were interior architects, they were commissioned to give the Levi's HQ a new interior. So they carefully took out the old interior, cleaned it up and reinstalled it in a slightly different way. So they got their new interior with the old interior. So this is where I say that designers have got to step up. We've got to be creative. There needs to be, there's going to be carbon taxes. There's going to be resource taxes as well. And I think if you're throwing away material, you're going to have to be penalised for doing it. I mean, I'm serious about closing mines down. If you close, we know what it's like with a bad supply chain. That's exactly what we've got at the moment. One thing I would say with the Glyndebourne project is we're not affected by the supply chain issues so much, because we've got the materials. The frame of the building was growing on site. So if you're reworking existing stuff, if you look at what's around before you start importing stuff, you're going to avoid so many problems with supply chain.
Yeah, very, very resourceful, that project. Oh, there's one last question, if I've got time to sneak that in before we must finish. Are the LETI recommendations and things like the reuse likely to become law anytime soon?
Ask Michael Gove.
Yeah.
I mean,
maybe we should.
I think they ought to be. I think it's, you know, local authority. My understanding at the moment is the people that I can talk to in an informed way, or who took back to me, a bit like you did, Tondra, with the mycelium. You obviously know as much as I do. I mean, a few years ago, I was on my own talking about it. So the great thing is that local authorities do know what to do. That's why I'm heartened. It's no coincidence that they committed to a climate and ecological emergency, the declaration of, and committed to net zero carbon, because there's knowledge within these local authorities. They know what they're doing. It's just the vacuum of intelligence right at the top at the moment is scary. So yeah, we need to do something about that. But who knows? Yeah, when I showed the slide of Boris Johnson, the good Boris, I actually, it was from a couple of weeks ago when he said we need to grow up. I was thinking, God, I agree with him for a change, you know. So yeah, who knows?